Well, welcome to the Satellite Application Virtual Training for Students organized by the AMS Satellite Meteorology, Oceanography, and Climatology Committee. And the goal of these training sessions are designed as an opportunity for our students to take the summer and winter break and learn new and interesting satellite applications enabled by the research activities and the new satellite data products conducted by NOAA and other federal or university labs. My name is Wang. I'm a professor here at the College of Engineering in University of Iowa. I'm one of the AMS SATMAC members to plan this meeting of this session. Besides me, there are also several other members who have been very helpful to plan these activities, and I will show their names in the chat. In the summer 2021, we had 4 training sessions for students on the topics from satellite data access and visualization, remote sensing of smoke and dust, to sea surface temperature and sea ice. So in case you have missed, all the past training sessions have been recorded, and you can access them via the MS website, which I will also provide that in the chat. Today is the first of 2 sessions we plan for the winter break in 2022. And we are glad and fortunate to have Joseph Patton and Scott Rudlosky to talk about remote of lightning in both sessions. Today's session focuses on the introduction of GLM, the global lightning mapping, while the tomorrow's session will focus on the GLM's application and case studies. Today will be primarily focused on the introduction of GLM. Joseph is a research scientist with the Corporate Institute of Satellite Earth System Studies at the University of Maryland, College Park, focusing on lightning research and training. And Dr. Scott Rudlosky is a physical scientist with NOAA and also co-located with the College University of Maryland College Park. He is also the NOAA Nested Star scientist for the GLM. So fortunately, with my limited knowledge of lightning mapping, I cannot find other 2 people that are more knowledgeable and passionate than them on global mapping of lightning from space. So let's enjoy the rest of the session. So with that, Scott and Joe, thank you, and the floor is yours.
Thank you. Yeah, I usually don't have the camera here in my home office, so pardon the mess in the back here, but welcome everybody. We're excited to have two different sessions here to share some of what we know about the GLM with you. This first session today, as we mentioned, will just provide an introduction to the GLM observations. We'll show you where to find some of the imagery, and then we'll have a hands-on exercise where you can actually go find some of that imagery and bring back something interesting to share with the group. So we mentioned there's 2 of us presenting today, Joseph Patton and myself, Scott Rudlosky. Joseph has an interesting background. We both actually went to Florida State and studied under the same professor, Dr. Henry Fuelberg. Joseph then went on and was a weather service forecaster in Goodland, Kansas for a while. So he brings a very unique perspective because the main training audience for us is the weather service. So just a quick overview of the course today. We'll have a 30-minute presentation up front. I guess I should go back and have everybody click on this Slido link, or can somebody please put that in the chat box? If somebody could copy and paste that Slido link into the chat box. We're gonna have a few polls there. The first poll today will allow you to, well, it asks what kind of your expertise is with the GLM to start off the bat. And we'll ask that question again before tomorrow's session and then at the end, and trying to get a feel for what you may or may not have learned during this time. So yeah, if you could follow that Slido link and it'll be open. We just have 3 questions for Slido for this first session. The one that's open now, we'll open a second one up halfway through and a third one towards the end. So not a whole lot of heavy lifting. There is a chat feature that's available over at the on the Slido link, and we will be monitoring that as well. So feel free to add questions or comments, especially if it's something that'll help you to better understand the rest of the presentation. We'll try to keep an eye on that and address any questions. So be sure to check out that Slido link. So again, we'll have 30 minutes off the top here just to present some of the observations and where to find them. And then we'll have 15 minutes for you to kind of go work with that website and put together a couple of slides. And then we'll come back and discuss what you found. Tomorrow is a longer session. We'll get more into the applications of the GLM, and I'll talk more about this tomorrow at the beginning of the session. So what is the Geostationary Lightning Mapper? Well, it's the first of its kind instrument. There's two of them now, and with the two combined, it provides extremely broad coverage. It detects total lightning, so both intra-cloud and cloud to ground. And so you're able to see quite a, not just a broad spatial area, but we see it continuously, so very fine temporal resolution as well. And so it's still a relatively new instrument, 4 or 5 years in. So the capabilities, products, and applications continue to evolve, and you'll see that as a common theme as we're presenting today. And I'll go more into this tomorrow, but are you guys, somebody, can you see my pointer if I have it on this screen?
Yes.
Great, thank you. So you'll see there's a lot of texture within these distributions. And so what we'll talk about today and tomorrow is what we can do with that information. So this first animation here, it shows the same lightning flash from both the GOES 16 and GOES 17 GLM. What you're seeing is a plan view of the flash evolving in time. This is a time series on the bottom with the energy on the top and the area on the bottom. The top panels just shows, the top and side panels just show how much of the frame is illuminated. So we call these flash skeleton images, and you'll see lots of these over the next, especially today, but some tomorrow as well. So really, this stresses that the lightning, by detecting the optical energy at the resolution it does, it really isn't, it's an imager rather than just a detector. It gives us very fine details about the lightning. If you look at our predecessor instrument, it was on low Earth orbit, and so it just catches snapshots as it goes by. There's actually one, the spare or the backup is on the International Space Station right now. It's called the Lightning Imaging Sensor. We studied 9 months off the bat for the GLM, and it would have taken the trim list 35 years to sample the diurnal cycle. So that's how big of an advance this is in our ability to see lightning. So here's another example. We have the GOES East and the GOES West. So the GOES S is out in the GOES West slot now. And again, here's another example of both of the perspectives at the same time. And what you'll see on the bottom here, if you look, these flashes lasted over 5 seconds, so 5.53 seconds, or actually 6.3 seconds, and over 6 seconds. And so this is, we're speeding it up, or speeding it up, but we're showing you, we're slowing it down so that you can see the detail. But it still is something that evolves over quite a significant amount of time in terms of lightning. So by having two up there, we have twice the data. I show the image on the left here. This is from the GOES 16 and this is from the GOES 17. And when we launched the GOES 16, we really didn't have any idea what we were up against in terms of the challenges we faced. But by the time the GOES 17 launched, we had really ironed things out. And this is with the out-of-the-box settings. So once the satellites launch, you have to make some tweaks. But we had a pretty good right out-of-the-box setting. And so right from the beginning, we started to get coincident data that we could do some really neat analyses with. And then I have the video on the right playing there to show you just how broad the perspective is. So this is just from the GOES East, and we're seeing, almost all the way to Africa. And so you put the two together and you just really cover a very broad area. And this slide here, this is the kind of latest and greatest from Michael Peterson, who works at Los Alamos National Lab, one of the leading GLM experts. And what he's done is combined a number of different observations. And what you see there, the white lines, those are real GLM observations. And so you're seeing a very intricate flash or series of flashes as they evolve in time. And what's new about this is that he has used information that he can pull from the lightning distribution, and he's added a third dimension. So the GLM natively just assumes that the lightning occurs at cloud top, but by looking at how the light is traveling through the cloud and with information about the cloud, he's able to estimate how high the lightning is occurring. So you can see some of it here he has coming down into the cloud, and then this is more along the top of the cloud. The gray that you're seeing is a 3D radar and satellite composite that he put together with Python. So I'll let this play through again, and just to show you how elaborate, or what the structure the GLM can resolve. And so a series of lightning flashes like this is very, very interesting to look at and provides a lot of science in and of itself. But if you're a weather service forecaster wanting to use the data for issuing thunderstorm or tornado warnings, this isn't the format that you would like to use it. And so a lot of what we'll talk about today, and Joseph will start on the following slide, is how do we take these very fine observations and quantify it and provide a product that the forecasters and others can use to benefit the public. And so we'll go ahead. Joseph takes over now for the next set of slides.
Thank you, Scott. Wonderful job on the first part. And thank you, John, for the introduction. Do you want me to share my screen, or does someone else want to keep driving the slides here?
I can continue to drive. Just let me know when to advance.
Okie dokie. Thank you, Scott. So like what Scott said, one of the major motivations for conveying GLM data is being able to show forecasters who need that lightning information as much information as possible in as quick as time as possible. So the GLM observations, as you've seen, those fundamentally differ from the ground-based lightning data that it's most familiar to NWS forecasters. A lot of them are used to seeing just a point to represent a lightning flash, when really the GLM provides this two-dimensional and even three-dimensional aspect of where the lightning is occurring and over what area it's occurring in a way that forecasters haven't really seen from ground-based networks. So the initial demonstrations revealed that the early NWS tools were not well suited for viewing this real or raw GLM data, and that motivated an intensive effort to develop a whole suite of gridded products that are images that show characteristics of these lightning flashes to operational warning decision makers. So these gridded GLM products, they disseminate that spatial footprint so that that area over which the lightning is observed. And it also, in turn, greatly reduces the file size and makes it more efficient to transfer that information to forecasters. So the gridded GLM products are just gridded imagery that's re-navigated to the GLM event latitude and longitude. Re-navigate the GLM event latitude longitude to the 2x2 kilometer ABI fixed grid. So in that way, it allows the GLM gridded products to be compared directly to the other geostationary satellite products from the ABI, such as infrared or visible satellite imagery. Next slide. So one of the main GLM products is flash extent density, or FED. And flash extent density is essentially just a number of how many flashes are occurring or coincident within each grid cell during a specified time period. So in this imagery on the right, we have a 5-minute window. And in each image, you're seeing a 5-minute accumulation of all of the lightning strikes. And the warmer colors indicate more flashes occurring in that window, and the blue or lighter colors indicate fewer flashes happening in that window. And you can see that there are portions of this mesoscale convective system where there are much more lightning activity than others. And that increased amount of lightning activity may give forecasters a heads up that that portion of a thunderstorm or a complex of thunderstorms may be more likely to produce severe weather. So those updraft cores are typically indicated by those greater FED values or more lightning activity. And that can be an important factor or an important byproduct of the occurrence of severe weather that can be observed using the GLM gridded imagery. But sometimes these rapid updates can be too rapid. So the GLM takes a snapshot every 2 milliseconds, and it's generating these gridded imagery products every 1 minute. But as you can see here, the 1 minute imagery is a bit choppy, and it may be difficult to establish trends looking at just the 1 minute imagery. So the 5 minute imagery provides a smoother, more rounded out way to observe how the lightning is occurring. And it also gives a clear depiction of the trends, which are going to be important for making warning decisions. Next slide. So one of the other main gridded products that's used by the Weather Service and other operational forecasters is minimum flash area, or MFA for short. And minimum flash area is the size in square kilometers of the smallest flash that occurs or over within that grid cell during that specified time period. So in this case, we can see that same convective system that we saw with flash extent density. Now we're seeing it with a minimum flash area. And minimum flash area is showing that very small flashes are happening along the leading edge of this convective system, which is what we would expect. We would expect those updraft cores, those stronger updrafts, to have more frequent and smaller flashes. So they should stand out as higher FED values and lower MFA values. And in this case, minimum flash area, those gold pixels are highlighting the small flashes in the strongest updraft cores. And then those purple pixels, those are the very large flashes. And those are mostly occurring in the trailing stratiform region of this MCS. And what we've done here in this example is we've also overlaid those little blue circles are severe wind reports from the National Weather Service. And typically, but not always, those severe wind reports are pretty well co-located with the most intense parts of the updraft course in this MCS, which you can identify from the gold or yellow MFA pixels. Next slide. Okay, and the third gridded product that we want to talk about today that's most widely used is called total optical energy, or TOE. And total optical energy is what it sounds like. It's just the sum of all the optical energy or brightness observed within each grid cell during that time period. So total optical energy is essentially telling you, regardless of how big the flash was or how small it was, how much actual brightness or light was observed by the instrument from that flash. And that's what TOE, or from those flashes that occurred in that time period. And that's what TOE is expressing. So bright regions in the TOE indicate the most energetic convective cores. And they may sometimes be co-located with severe weather. And also those lightning channels, bright regions in the TOE indicate lightning channels within extensive stratiform flashes. So you may often see sometimes that you will have bright regions of TOE stick out in those stratiform regions that we saw, like with the MFA product. So even though those flashes may be large and only have one or two flashes, they also typically end up being very bright, which we can see with TOE. So real-time TOE, or total optical energy imagery, is only available at the weathernerds.org website, and we'll get into how to access this imagery in a moment. But the image you're seeing on the right is an animation, I believe, from, looks like Hurricane Laura, and it shows the GOES 16 IR as well as the TOE from the GOES 16 GLM. Next. And this here is just a zoomed in region where it's showing you those TOE values. And we can see that persistent lightning occurring near the eye of this hurricane, or eye wall of this hurricane. And that lightning in that area of a tropical cyclone often indicates that it's either mature or strengthening. Oh, yes. And I see that question. Thank you, Amy. So the units of TOE are in femtojoules, or joules times 10 to the negative 15. And it's essentially just a measurement of how much energy or brightness is being observed by the GLM. Next. Okay, so this is more of like a 3D or global view from Michael Peterson, one of his online web tools. Um, so to orient you with what's going on here, there's two things that are being displayed. So each one of these towering pixels here, that's lightning being observed, and the taller towers are more flashes, right? So the taller the tower is, the greater number of flashes are being observed in that one particular area. And then the color coding is the size of the flashes. So what we end up being able to see here in this convective system is that we have smaller but more frequent flashes occurring on one edge of this system. And on the back edge of the system, we have fewer flashes because the towers aren't as tall, but the colors indicate that these are larger flashes. So this is another classic mesoscale convective system where we have smaller, more numerous flashes happening along the leading edge, and we have larger but fewer flashes happening in the trailing stratiform region. Okay, thank you. And so now we're going to switch into talking a little bit about resources that are available for you to learn more about the GLM and access the graded imagery. So we'll start with the NWS VLab or virtual lab webpage. And there's a specific VLab page just for the GLM, and the link is there. And typically the VLab is a resource that's directed toward National Weather Service forecasters, but a lot of this information is also publicly available. And what this VLab page serves as, it's a place where you can get information on the GLM graded products and see more example imagery, as well as get links to additional training materials. You can see some of the literature that's been recently published about the GLM, and also get some in-depth example use cases showing how the graded imagery was used to make a better forecast or a better warning decision. Next slide. Okay, so when it comes to accessing GLM imagery, there are several options. The first one that may be a good first place to start is the STAR NESDIS GOES viewer. And what's playing here is a little video that I took the other day of me navigating on that website. And so you can pick a region, and then you can select a product. In this case, I'm selecting flash extent density over their GeoColor, which is a combination of different ABI products. And once you find imagery you like, you can simply click download to download the animation. And then you have the imagery that you would want from that sector view. And there are lots of different sector views to choose from. And that's what makes this, in my opinion, the STARS GOES viewer one of the more powerful tools, is that you can select from a list of different regions and different products in a way that's very quick and user-friendly. Next slide. So one of the other websites that we've already talked about already is the Weather Nerds website, or weathernerds.org. And if you just go straight to that link with the /satellite on the end, you'll get a page that looks a lot like this. And if you click on the tab that says display options, you will see several options to display lightning from GOES 17 and GOES 16. So the first thing that you see is there's flash extent density and there's total optical energy, like what we talked about, and you can turn either one of those on or off. And then also where it says G16 lightning and G17 lightning, those are flash points. So it's like a singular point derived from the flashes observed by the GLM. And a lot of forecasters find the points to be helpful because it's similar to what they've been using with the points from the ground-based networks. An example of what those points would look like, you can see in the top right here. But like we said at the beginning, we really want to shift the focus here to the gridded imagery, because that's the most efficient way to show, like, say, for example, the spatial coverage and other important lightning characteristics, which the points don't necessarily show you. So if you want to find flash extent density or total optical energy in a gridded imagery overlay, weathernerds.org is a wonderful website to visit. And as far as I know, they're the only website right now that is hosting real-time total optical energy. Next slide. Okay, so one of the other really popular web pages to get GLM imagery is the College of DuPage Meteorology website. And if you go to their satellite products section, this is what that page will look like. And it's a little bit confusing because if it's oriented to where you can select products on this left-hand side, like visible satellite or IR satellite. But in order to add in the GLM data, you actually have to click on this little globe here in the top left where it says product overlays. And then from there, you'll see a menu that pops up, and on the Goes Derived tab, then you can click on GLM flash density or the GLM flashpoints. So it's a little bit more tricky to get to on the College of DuPage website, but if you're already used to using that, it may be a really good resource for you to overlay different satellite products using that website. Next slide. Okay, so this is the globe that we were just talking about earlier from Michael Peterson, who is a wonderful expert in this field. That link there will allow you to look at these real-time or recent GLM imagery, actually from any time in the past 7 days. And you can select products for the shading. Now, the height is always going to be the number of flashes, that flash density, but you can choose what color that represents, like if it represents the size of the flashes, or if it represents the flash direction or the anvil cloud. So yeah, so play around with it. See if there's anything that strikes you as being really interesting. This is one of those tools where it's really versatile and not standard. So you can really find something that looks really interesting in a way that a lot of people haven't seen before. And then if you want to adjust the playback speed, you can do that on the bottom left by moving that little cursor. And then getting imagery. And then as well, you can also change the background map. So right now we're seeing just one background map, but you can change it to Earth at night with all the cities lit up, or change it to some other satellite view. And then finally, you can, I think I mentioned this already, but yeah, you can choose from any period, any day time over the previous 7 days. Next. Okay. So there's also, there's a few places where you can go to get some archived imagery as well. So Scott will talk about this more in a moment, but for this upcoming exercise, you don't necessarily have to focus on just looking at something that's happening right now or happened within the last few hours. If you go to either one of these Dropbox links, you will find some really interesting flashes that have occurred over the past few years while the GLM has been running. And we encourage you, if you would like, to explore these Dropbox and find, like for example, the animation playing here in the bottom left is a flash skeleton. So showing you literally the flash channels as they're happening. And a lot of these flashes end up being really interesting to look at in this perspective as well. So feel free to peruse the flash skeletons Dropbox as well, and just find something that strikes your fancy and tie it into something, some sort of weather pattern or something that's going on there. Next slide. So the final thing I want to talk about for the accessing GLM imagery is this lightning.umd.edu/GLM website. And that's sort of aiming to be a one-stop shop to promote proper use and interpretation of the GLM products. So a lot of the resources that we've talked about already today, those are going to be provided as links in that website as well. And a lot of the imagery we've shown today, you can see there. So if you forget how to access all these websites, then that website may be a good place to jog your memory. Next slide. Okay, and
All right.
so I think I'll let Scott go ahead and take it on for the hands-on exercise.
Great. Yeah, thank you, Joseph. Perfect. Covered it. I think we right on schedule in terms of what we were planning. I wanted to mention a couple slides back. In addition to these flash skeletons, in each of these regions, there's a daily composite image that comes out. And so you can go look at any day that you'd like over the past year or so, maybe more. I forget when he updated to this new format. But so those are the two links here. If Dyla or Joseph, while I'm describing this exercise, could you copy and paste all these links? Probably Joseph, you have the slide deck. If you could copy and paste these links, they're all together on this last slide into the chat box, just to make it easier for folks to find the various things.
Yeah, I'll do that right now.
So what we'd like to do here, we'll go through and answer some questions. I saw there was questions and some discussion on the chat. I know on the, if somebody, Joseph or Dyla, if you could close the initial poll question, I guess, and open the second poll question now. If you have questions, either the Slido Q&A tab or on the Zoom, you can add questions just like some folks have been doing. And so we'll try to address the questions that way. In terms of what we'd like for you to do now, we'd like for you to use some of these things that we just showed you. And so nothing too involved, and it really is, it's pretty loose. We'd like you just to go use any of these websites that you find interesting to look at something that interests you. And so just focus on any scale. You can look at individual flashes, maybe pick some skeletons that look interesting and do things that you didn't expect them to do. Or you could look at the whole hemispheric perspective with some of the composite imagery that we showed. You can do real-time or archive cases, whatever you'd like. And then just put together 3 PowerPoints or Google slides. And we'll find, I don't think I started a folder yet, but we'll put a link into a folder to drop these in. And just take like 10 or 15 minutes. It doesn't have to be anything professional. Just put an animation in there. I don't know if we listed, we didn't list any tools here. Tomorrow we show you some tools where you can actually merge some imagery. So just use what you can find here that's already kind of prepackaged and put together those slides. And we'll keep the line open here and provide additional instructions. And if anybody has any questions that aren't being addressed in the chat box or that you think everybody could benefit from, feel free to come off mute now and ask your question. But go ahead and get started, whoever's ready. If anybody has questions before we get going, go ahead and ask them now. And all the links are in the chat box there. While you're working on this, I wanted to mention again, over on the Slido, we have a new question that's open. I saw there was only 9 responses for the first one. The second one, we're going to use to kind of guide where our emphasis is placed tomorrow in terms of which aspect is of most interest to the broadest number of you. And so if you get a chance in the next, say, 20 minutes or so, click on over to Slido and answer that poll question so we get a better feel for what to emphasize tomorrow. We're about halfway through the hands-on exercise. Anybody have any questions or anything to share with the group? Otherwise, I wanted to note, I did add a Dropbox link to the Zoom meeting chat. I think you should be able to upload your slides there. Please let me know if anybody has trouble with that. a couple more minutes to wrap up your slides. You don't have to send them right away at 12:45, just sometime in the next couple of minutes after that. And I'd also, if anybody's willing to volunteer and share with us what you found, you don't necessarily need to go through your slides, but you could just, show us something or ask us to navigate to something that you found interesting. Pulled up the Weather Archive link. Went back a couple of days. Just one day. Some computers handle this website better than others. If anybody's watching my screen, one reason I pulled this up was to show you, we won't talk a lot about data quality, but we have what's called a hot pixel out here. It's a pixel that triggers much more frequently than it should. It's not real lightning. It's out there in the middle of the Pacific. So you can see it shows up as you zoom in here, quite pronounced here. That's not real lightning. It's just one pixel, and doesn't look normal either if you were to be watching pretty much any of the products. One thing I check pretty much every day. It's really neat as a scientist to be able to watch. So I write a lot of papers about climatologies, and the patterns lightning produces over a very long period of time. But now that we have these websites, we can watch those climatologies come together. So just about every day I'm working, I open up this full disk for GOES 17 and marvel at the lightning. We're out here in the middle of nowhere, where ground-based networks see some of that lightning, but certainly not all of it. And so there's just some really neat patterns if you come look at it. Over the month of December, there was tons of lightning out near Hawaii, and here you can see lightning way up north. That's a really cool way to use this site. And they have these canned images too. So I actually have a script that every day it downloads these images. Well, it's not every day, it's every 5 minutes. It downloads certain images that I'd like to keep, and then I create animations on my own after the fact. We'll talk more about those tomorrow. I don't know if anybody focused on it. I guess today is not the best day to look at it, but one really neat pattern you get to see this time of the year is the influence the rivers have on the cloud patterns and the subsequent thunderstorms down in the Amazon region. And I'm sure folks have already done it, but if they were going to, when I go through, you can go through and look at these different images for different days. For the skeletons, what he does is he just produces the most interesting flash on any given day. And so sometimes it's real lightning and sometimes it's not. And so I don't know if I thought maybe somebody might find a really funny looking flash like this and say, what the heck is that? That can't be lightning. And truth is, it probably isn't lightning. It's some kind of artifact, either glint or something, some kind of, I think Joseph coined the term ghost in the machine. Really what the GLM is, it's an array that's moving electrons around, and to do it as efficiently as it can, sometimes they cause known data issues. And so most of that has been mitigated, but sometimes really funny things sneak through. So I'll be interested to see if anybody found any of that stuff and put them into their slides. It looks like nobody's uploaded anymore. Maybe nobody can. Has anybody tried?
If anybody's having trouble uploading their slides, I put my email in the chat box. So just send them to me in an email and then we can go through them.
Great. All right, so it'd be great. We got 10 minutes left in this first hour today. It was mostly an introduction. We wanted to kind of show you the things that are out there, give you some tools, and maybe you'll have time later today to look more at this. You're welcome to upload slides later today if you'd like. I'd like to hear from one or more of you. If somebody could, Dialer or Joseph, if you could close the second poll. It still looks like only 10 folks have found their way over to Slido, and open that third poll. It's just, what's the most valuable thing you learned today? And that doesn't need to be very elaborate. Just, is there something you learned today that stood out above other things that you might have learned in our short session here today? And then, yeah, I'd like to hear from at least one of the students. Anybody brave want to introduce themselves? I guess tomorrow we could go around the room and have everybody just say hello, but it'd be good to hear from at least one or two of the students, if not more. Where you're from, what you're working on.
Hello, I can be brave enough to go. Can you hear me okay?
Hey, welcome. Thanks, Adam. Yep, we do.
So my name is Adam Weiner. I'm a second-year master's student at the University of Alabama in Huntsville, studying a case study really of a severe QLCS or squall line which pushed through here in the cool season. It was a high shear, low cape situation, and I actually wanted to look into this lightning data to see if I can find if the updrafts were tall enough to reach, I guess, the freezing level of potentially produce lightning. The case is from 2020, so it's pretty recent, but I'm really interested in seeing where I can find archive data and have it not have to deal with coding up a way to visualize it, or if there is a way, it's fairly easy. So that's my main reason for coming here.
Great. Yeah, that's I appreciate you taking the time. You're sitting in the right place, Alabama, Huntsville. Some of our, a lot of our GLM team sits there too, kind of right down the hall from you. So we decided today not to get into the coding, and tomorrow not to get into the coding aspects, but there are lots of tools available. And so we certainly welcome you to follow up if the links to the archive imagery that we provide doesn't quite meet your needs. We're happy to follow up with you and help you find the right tools.
Awesome. Sounds good. I really appreciate that. Thank you.
Certainly. Anybody else introduce themselves? I'd hate to call on people because I always didn't like that when I was a student, but we'd love to hear from you. And if you're talking, you're on mute. All right, we'll find a way tomorrow to break the ice a little better.
Oh, hello, can you hear me?
Yeah, certainly. Hello, Paul.
Hi, how you doing? Yeah, I'm having trouble with my slide set. I'm going to try to email it, I think. But I just found using the WX Arch webpage, I found the ability to go back to December 29th during the tornado over the supercell that went over Kentucky, and kind of a nice added little data set to go along with my little in-house case study I'm doing on that particular event. So just thought I would add that I found that, and I'll send it along.
Perfect. Yeah, really glad to hear that helped. That 7-day moving window is really nice to have. Yeah, I look forward to seeing the slides you put together.
Okay, thanks.
Yeah, and I guess for everybody, that Dropbox thing I just threw together last minute, I'll get that better tomorrow. So yeah, just email in the Zoom chat. Joseph put his email there, joseph.ray.patton@gmail.com. So just email him as an attachment. And there's really no rush on it. I know 15, 20 minutes isn't quite enough. I just wanted to get you guys going on it. Does anybody have any questions about what they found or suggestions to others for something to go look at? Or if they'd like to do what Paul did and just tell us what you found real briefly, which website you used and what you looked at. So personally, when I'm working with this imagery, one of the main limitations is 15 megabytes that you have to worry about for Twitter. And so when you go to the GLM web page, the animation that's canned is sometimes too big. So you have to go get just the right amount of frames. And then Twitter kind of butchers the resolution anyhow, but that's another story for another day. But my go-to was always Weather Nerds until the Star Goes viewer recently added those sectors. And they also recently updated so the GIFs that you export are prettier and cleaner. Some of the colors used to drop out. And so I'd say that's my go-to webpage now for looking at real-time data. And either of those sites, the Weather Nerds or the Goes viewer, they work on your cell phone just as well as they do a desktop. So you can literally see the GLM data whenever, wherever, in a zoomed in view at that. All right, we got a couple more minutes here, so I'll show you on the Weather Nerds page. I guess there's not a lot of lightning, is there, with the Weather Nerds, so that might not be as useful today as it would be on other days. So, but yeah, you zoom into different areas, and as Joseph was saying, you can change what displays. I was going to mention, so in this field of view, there's 14 GLM flashes right now. So if you change the display options, you could update the plot. No flashes there. I didn't mean to zoom in. Yeah, that's not the best site to use today.
Yeah, Scott
Lightning
just
is
mentioned
elsewhere.
in the chat that's one of the other reasons why the Star website is nice, is because it's really easy to look at things which are outside the CONUS. He said he was looking at a tropical system near Fiji. Lots of nice lightning near the center.
That's great. Yeah, thank you for that. That's, yeah, for me, one of the most interesting things is looking way out there where you wouldn't think to look before you could. You can now. I should mention while we're here, on the Star Viewer page, we're obviously most focused on the flash extent density and geocolor, but they have a clean geocolor and they have these other RGB. And one of the prettiest ones you can see is the sandwich RGB. When you can see this for a big MCS, it's really, really something. But it's just a combination that combines the visible with the visible for the texture and then the IR for the color. So it really pops when you have big storms. And then the day cloud phase, this one's phenomenal. If you're looking at forecasting, you can see ice is a different color. And so you can watch these flashes turn from, I guess I haven't looked at it closely, but I guess cyan to green to yellow to orange. And that means that there's ice. And then the lightning comes pretty soon after that. So in addition to the GLM stuff we were showing here, there's a lot of other really neat tools that you can look at on that Star Viewer page. All right, so we're right towards the end of our time. I'll go ahead and stop sharing my screen. Is there any last minute questions or logistics? Joseph, Dial, am I forgetting anything? Other than we reconvene tomorrow at the same time, but for 2 hours tomorrow.
Thank you, Scott and Jill. Can you give a big round of applause for them? Thanks for your time. Harry. All right, I guess, Gary, do you have any, or anybody have anything to wrap up?
John, just might add that, of course, as you've already said, this video this session has been video recorded, and we'll post it on to the AMS community folder probably tomorrow afternoon.
Right.
So you can revisit. Go ahead.
Yeah, it might be good to also have the link for the summer training links as well. We were put together. Those are very valuable resources in my mind. I think we have a good intention here is that in the summer and the winter, many of our students may, sometimes the break could be long, and so it's a good opportunity for you guys to learn more about new things that you may not be learning from the textbook. So anyway, yeah. Thanks, yeah.
And just a reminder, this is Rex from the AMS. We are giving out the certificates if you attend both sessions. So if you do need or want the certificate of completion, please attend tomorrow as well. And then we will cross-reference the two attendance sheets and create certificates.
Okay.
Thank you.
Well, great. We're going to
thanks, everybody.
Yeah. Okay. All right, bye-bye then. I'll see you guys tomorrow. Bye. Have a good one.
All right.
Thanks, everybody.
thank
See you tomorrow.
Bye.
Bye.